We've talked about arrays before. Arrays are generally great when you know how many elements they're going to contain, but sometimes you don't know. Sometimes you want some sort of construct which can grow dynamically as you get more and more data. For example, let's say you're reading a file. You don't know how many lines it's going to take, so you cannot pre-allocate an array for storing the actual data. So you need something which grows dynamically, and this something is called a vector. So let's take a look at how you would actually initialize a vector with a few values. Let's say 1, 2, and 3. So the way I'm going to do it is I'm going to say let a equals vector new. So vec is the type that represents a vector with a capital V here, and we're going to add it some values. So we're going to say a.push, that's how you add a value. We're going to add the values of 1, 2, and 3. So I'll have 1, 2, and 3 here. Now, this isn't going to compile, and the reason it's not going to compile is because we're changing the value of a by pushing in additional elements. So by default, almost by definition, this vector value has to be mutable. Otherwise, you cannot actually change it and add more values to it. Now, we don't have any output for now, but what we can do is we can certainly print line the actual vector. We can say a is equal to, and let's use the debug output here. So we'll print the vector, and now just control F5 it, and we'll see what we get. So a has the values 1, 2, and 3. And obviously, since this is mutable and you have this push function, you can keep adding more values. So I can, for example, say I want another value 44, and then I can output the vector again. So let's print this out. So I have 1, 2, 3, and then I push another value. I get the value of 44. Now, what about getting a particular value, like the first value, for example? Well, one of the ways you can address the elements in the vector is using the same form as an array. So I can, for example, print line the fact that the first element, a at 0, has a certain value, a at 0. So I'm going to try and print out the first element in the vector, and that's obviously a 1. So that's what we're going to get. A at 0 equals 1. So one of the things I haven't talked about previously, and I should have talked about, is what is the type of the index into a particular element, because we have never really discussed this. We've just been putting numbers inside the indices of arrays and vectors and so on without giving it much thought. Now remember, when we talked about data types, I also mentioned the usize and isize variables, which whose size is actually the size of the memory in your system. So they can either be 32-bit or 64-bit. So now you're going to see why these are actually relevant, because let's suppose that I declare the index IDX to be an i32 value having the value of 0, and I try to feed that in here. Now, if I were using some other programming language, this would work just fine. However, with Rust, if I try to run this, it's not going to let me do it, because you cannot use a signed 32-bit value as an index of an array, because, well, guess what? First of all, memory addresses cannot be negative, and we have a signed value here. It doesn't make much sense. And the other thing is that I'm on the 64-bit machine, so why would I be using just 32 bits for a memory address? Once again, doesn't make much sense. So the type here has to be a usize. So it has to be unsigned, and the size has to match the size of the memory on my machine. If I do this, then it works just fine and it gives me the appropriate value. I just wanted to stress this particular point because it's kind of important. Okay, so we can certainly have the value printed out. We can also assign the value, so I can say a at idx equals to 3 to 1. I can run this and get my output. 312 rather, that's what we get. So I can change values and I can add more values to the vector. Everything is fine so far. However, what would happen if I had the actual index at 111? Well, in this case, as I run this, I get a panic. So the thread panicked because the index is out of bounds. So essentially I crashed the program. That's the only way that we can describe what actually happened here. So the question is, what can we do about it? What can we do to prevent us crashing the program. And certainly in the case of arrays, it's a bit easier because you always know the array bounds, so you always know whether you're going to hit an element or not. Whereas here it's a bit complicated because you never know how many elements a vector has. Now, one of the options is you just get the length and you check against the length, but another option is to use the get function. So let's imagine that I'm trying to get the element at the 6th position. I only have 4 elements in the vector, but I try to get the 6th position. So I try to get it using the get function. I say a.get at position 6. Now, the get function is special because what it does, instead of just crashing your program completely, is it returns an option type. And the great thing about the option type is you can match against it. So I can say match this option type, and there are 2 possibilities. So if I do indeed have an element at, well, in this case it's the 7th position since the index is 6. If I do have the element at this position, then I'm going to have a sum. So I'm going to have sum of x, and I can say that I can actually print line that a at position 6, so the 7th element here, is equal to this value. However, if I fail, if there is no such element, then I get a none, and in this case I can print line error no such element. No such element. All right, so this is a very safe way of us figuring out whether in fact the element actually exists. So at the moment it doesn't exist, so I'm going to get the error value. Let's actually run this. So oh, it's still panicking because of the previous printout. Let me fix that for a second. Okay, so let's see. Oh yes, it's this bit, so this has to be a 0. Okay, so error no such element because the element at position 6 does not exist. However, if we change it to something like 3, for example, then we're going to be just fine. And in this case, a at 3 is equal to 44 because we get, instead of getting a none, we get a sum. So as you can see, this kind of option duality, having either none or sum, lets us write safe code if we want to access a particular specific element of the vector. Okay, now let's talk about iterating a vector first of all. So iterating is actually quite easy. You just say for x in a, so you iterate the vector in all sorts of ways, and you can print line the actual value. So in this case, I'm going to just print out the value of x, and that's going to print the entire vector. Let's actually run this. So I get 2, 3, and 44. So and of course 312 that we've changed up above. Okay. So adding elements to the vector is easy. We've already seen this. You use this using the push function. Just push a value to the top of the vector. You can think of a vector as a stack, in fact, where you push the values and then you take the values on top. So as I push the 44, I can then print line the vector in debug format. Let's print out the vector A. Just going to run it like so. So I have 312, 2, 3, 44, and then 44 again. It seems I've done it twice. We did it previously here, and I've reused the same value here. So we now have it twice in there. Now, what about removing the elements? Well, if you want to remove an element, what you can do is you can pop the element from the end. So if I want to take off the final value, let's say the final value is going to be 77 instead. So we'll have 77 here on the end. Now what I can do is I can both grab the final value. So I can say let last element equals a.pop. So pop removes the final element, removes the 77, and also puts it into last element. But it's not as simple as that, because imagine what would happen if the vector a was empty. Then doing a pop on it would be kind of meaningless, and in some other programming languages, it would just crash the program, but not in Rust, because what happens as a result of pop, just like the result of get, is you get an option. So if you do have elements in the vector, then the result of pop gives you the sum of 77. If you don't, then it gives you a none. So what we can do in this case, let's suppose I want to print out the last element. I'm going to print it out using debug output. I cannot just print out the actual value because last element, this thing, it's not an integer. It does not have the value 77. It is instead, in our case, sum of 77, which is different. So let's print out last element. Last element is, let's use debug output, and then let's print out the vector itself, also using debug output. Oops. There we go, colon question mark, like this. So last element, and then A. There we go. Okay, so let's run this. Let's see what happens. So we have a vector with 5 elements ending in 77. We pop the last element of the vector, and then the last element is sum of 77, and A now contains the first 4 elements. The last element has been removed. So effectively what I can do if I wanted to is I could pop each of the element of the vector one by one, thereby printing them in reverse order. One thing that you have to realize is that if you want to get the last element and its actual value, then you cannot just use a sum in this location. For example, what I cannot do is I cannot say something like let sum of last value equals a.pop. I cannot write this and then start using last value for the final element. Why? Because last value might not be initialized. You might not have anything in the element, so you might not have a sum. And in fact, when you try to compile this, you will see that it's a refutable pattern in a local binding, none not covered. So you're essentially trying to assign something which can be sum or none to a sum, which doesn't make much sense because it might not be a sum, it might be a none. So this is why you cannot do this. Okay, so let me show you how you can actually do this assignment. A bit more cryptic case. So I'm going to pop the elements out of the vector and print them in the reverse order. So while let sum of x equals a.pop, I'm going to print line the x. So this pops all the elements, prints them in reverse order. So we get 44, 3, 2, and 312. And by this line, the vector is actually empty. So how does this work? Why is this at all possible? First of all, you'll see that inside the while condition, we have a variable declaration. We have a let binding, effectively. So this is valid. And in fact, what we're saying is we're saying that while the result of a.pop yields us a sum of x, we can use that x to actually print it out. But as soon as we get a none from a.pop, this whole thing fails, and therefore we break out of this loop. Now, I know it's not very intuitive when you look at it, but this is one of the ways you can iterate something which returns you an optional. So a very good demonstration of just how powerful the Rust language actually is.